So now if you come here, so if you see there are something which is already catching my eyes. Now you see there is a process ID which is 2572, which has a process like notepad.exe, which is calling a file inside downloads named docker.ps. Okay, let's do one thing. Let's open the file, but I don't want to run the file because I don't know what this file gonna do. Yes, it looks like something harmful on that particular file, and oh my god. So you see, this is the code that is being run on the machine, which is being called by notepad, and this file was calling itself as a parent process. Let me do cat stage 3. Now we have our full code. Isn't it very interesting that from like starting from the beginning, whatever we are doing so far, we have finally, guys, explored what is the gibberish code inside that, and we have explored everything. Now our Yara scan has been done. Now this is quite surprising. We already knew that this machine is infected, but we see this machine is also having 2 matches. So that means attacker has spawned up this machine as well, and this machine is also infected, right? So okay, let's go back to the IOC section, and you see these are the all IOCs we known, but this was a new IOCs as the IP address IOC that we have identified just now. Okay, interesting stuff. So you can, by the way, you can do all those things by your own, but this actually gives you a full depth of analysis. What's going on, guys? Welcome back to another episode of BlackPerl. Today is day 11 of my free DFIR course, and I hope your coffee is ready because you need coffee very bad for this episode. This episode we are going to blow away with the technical stuff. I'm gonna show you how actually a real incident can be handled from a like black box analysis, like then memory forensics, malware investigation, static analysis, dynamic analysis, writing Yara, then contain the incident, and then finally every damn thing that a SOC analyst or a DFIR analyst has to do if there is a P1 or P0 incident. Okay, so the incident basically start when there was a fire caught up in data center. Okay, and that's a real nightmare. Okay, so we could have thought that okay, the incident could be a like a physical threat, but guess what, it turned out to be a cyber attack, and someone actually spawned a minor code inside one of the servers of the data center. Okay, and that was a real nightmare. Okay, so we are gonna explore the whole damn thing in today's episode. I have tried to make it a smaller kind of demo session for you guys. So what I have done in the actual incident, I'm gonna show you each and everything step by step, starting from the beginning, how we have handled that incident, how we have like decoded the unobfuscated code to identify the IOCs, how we can extract the IOCs, how we have defined all of the matrices, writing Yara, each and every damn thing. Okay, and the most important and exciting part, guys, I am going to give away a e-learning security certification program to you. Okay, so the certification name is Forensic Practitioner, and it is around $400. Okay, so here is the deal, how you can participate in that giveaway contest. Okay, so if you think that you should have that certification and you have to grab that certification, maybe you want to achieve some interview or you want to grab your next cybersecurity and DFIR job, so what you need to do, you just need to share this particular video to your LinkedIn profile. Okay, and you have to tag me, Archan Chaudhary, and BlackPerl. Okay, so I'm gonna choose randomly from all of your posts, and I'm gonna like announce the winner in the next week or next to next week in the LinkedIn itself. Okay, and we will take it from here, how you can get the coupon and all those stuffs. Okay, and don't forget to comment in this particular video that you are participating in the giveaway and you have shared the video in your LinkedIn profile. Okay, So that's all, and I don't want to waste any further time, so let's dig into the particular video because we have to take a long journey and it will be exciting, guys. So let's do it. Okay, so guys, so this is the actual machine for which we have all this massacre. Okay, now what happened, basically we have logged into the box, and this is kind of, like a total black box for us, and we don't even know like what the hell is wrong on this machine, right? So you cannot do anything on this machine because the machine is kind of, quarantined, and you have been given to this machine and you need to investigate and find out what went wrong to this machine and why this all flames, why this all fire came up. But one thing for sure that we know is that the power usage of this machine was like, like hell. Okay, so that's the reason might be this machine got caught on fire and all this thing got blown up. Okay, so now the first thing is that since we do not know like what actually we are dealing with, so it's a best idea like to first capture the memory image of it, because the machine has been quarantined but this machine has not been shut down or something like that. Okay, so the machine is still there in the network. We have quarantined it, but right? So the first thing, okay, so the thing is that we are going to use Binalize. Okay, so that is our like endpoint forensics workstation. So if you want to learn about Binalize, so I'm not gonna cover anything on it, so you can go to my other videos that is coming up somewhere here, and I'll put the link in the description box, so check out that awesome tool. So now what the first thing, so first thing is that, so let me check what is the machine name. Okay, so machine name starts with win. Okay, so basically, yeah, so this is the machine that we are gonna target. Okay, so now what actually we need to acquire something, and we need to quick RAM and page file, because that's the thing we are looking for to capture, and we need to analyze that particular sucker, and we need to understand what went wrong on that machine. Okay, so now what we will do, so task name I will write as memory capture probably. Okay, and I will hit so path means on which path basically I want to store that particular file, so I'll put it like that, so that's fine, and I'll hit a start. Okay, so what actually it is doing, I am basically capturing the memory dump of that machine, and it gonna give me everything, and I'm gonna analyze it for sure. Okay, so now side by side what I am gonna using, basically this is my forensic workstation. Okay, the shift forensic workstation, and I'm gonna use this particular machine, okay, for doing all those forensic stuffs and on those things. Okay, so let's see, it might take some time, but as you see, it's heavy fast. Okay, so it's again a feature of Binalize, and it's damn fast. Okay, so we are gonna proceed step by step because we are dealing with a total black box, and I want you guys to focus on each and every point of that particular machine, right? Because I mean investigation, because in this particular tutorial we are covering a hell lot of things. Okay, so and we even don't know from where to start. So memory forensics is a way where we can like actually investigate and actually identify a lot of stuffs. Okay, so this tutorial gonna be a like a little big, but if you want to become a successful incident handler and want to go deep dive and learn something, you have to watch the full episode. I don't care if you watch it like 1.25 speed or 1.5x speed, that totally depends on you if you can grasp it quickly, but watch this episode full. It's very, very important, each and every step. Okay, so now I am assuming that this particular sucker should be completed. We'll come back when that is done. Okay, now so as you see, the memory capture is done now. So what I have done in backend, so I have placed this particular memory image and I have taken to my forensic workstation. Okay, so there are multiple ways that you can do. You can use a S3 bucket. That's the thing that I have used. So what I did, I created a S3 bucket. Let me show you that what actually I have created. So if I open a S3 bucket, basically because the memory image was sitting on the air host, that is our management node. Okay, so I have explained again binarize in very detailed in my previous episode. Check out that. So while that is opening, so let me go back to my forensic workstation. Yeah, so this particular machine is our raw image. Okay, so what I'm gonna do, I'm gonna open up a terminal over here. I hope this particular thing is visible for you. Let me do one thing. Let me zoom in a little bit, if that makes sense, because I don't want to zoom it full, because there are a lot of stuff will be coming here, and you can easily lost control over it if you are doing anything else. Okay, so now, yeah, so this is the S3 bucket that I have created, and you see this is the same raw image that I have taken from the machine, and I have dumped into the bucket, and from the bucket I have downloaded the machine, the image, memory image over here. Okay, so quick stuff, our win_mem.raw is finally here. And what we know basically, because this is a 2K12 version of workstation, so what we can do, we can simply write like vol.py and -- info, because we want to know what are the available profiles to parse this particular machine. Okay, so now if we go back a little, if we scroll up, there should be somewhere all the profiles should be written over here. Okay, so now, yeah, you see these are all the profiles that has been written over here. Now if you notice here, obviously we know that was a cross 64 machine, and it was a and it was a R2. Okay, so let's do one thing, let's use this particular profile and let's see whether we can parse the image or not. So okay, so let me clear up my screen. So we are gonna write is as like -f, because that's the de facto of mentioning where is our file located. And if we remember, our file is located over here. Okay, so what was the name of it? Okay, I forgot, I keep forgetting my things. So ls winrem, obviously, so we are gonna write as vol.py, then as -f, and obviously then win.mem.raw, and this time we are gonna mention as -- profile. Okay, because that's we need to parse this particular image to a particular profile in volatility. Okay, and just to give it a try, we will mention as like PS list, because we don't know whether it's gonna parse properly or even not. So that's first thing that we want to do it, so just to see whether the image is getting parsed or not. So yeah, so as you see, these are getting parsed, so I believe the profile is fine now. So what I'm gonna do, I'm gonna zoom out a little bit, because it might look a little bit of clumsy for you guys, but yeah, so I'll gonna zoom out another thing. Yeah, so now you see these things are totally visible. Okay, so okay, let me zoom in a little bit. Okay, now this is fine. So now let's start the analysis. Okay, so from PS list there are a lot of things that you can find, so probably the process that is running on the machine, but as you see, something is hitting already in my mind, that you can see here I have seen something like tor.exe, right? Yeah, so you see tor.exe, so our server is running a tor, heavily suspicious, but we don't know what is this parent process, what are the other processes it running, right? So again, PowerShell is there. So what we are gonna do, rather than PS list, we can write something like PSX view. Okay, and also PS3 also we can see, because that's gonna give us the process tree of kind of structure, from where basically the all these stuff has happened, like what is the parent process of it, what the child process of it. Now if you come here and if we see here, so obviously win init is the parent process of everything. Now you see there is a service, obviously. So the process which doesn't have anything is a parent process, and which have a dot with it, that's a child process of that, and it's following the parameter like that way, dot dot dot, something like that. Okay, so for getting the full hands tutorial of a volatility memory forensics, again there is a video. I'll leave the link in the description, and check out the video in coming up here in the tag as well. Okay, so check out that if you want to learn a deep dive analysis of memory forensics. Okay, so I'm not gonna cover each and every damn thing of a memory forensics, but our intention to identify what is unknown from this particular tutorial. Okay, now if you see, there is a tor.exe which is running a single dot. Okay, so now that is running a zero net.exe. Now I don't even know what is that 0.exe, because this is a parent process of it, and that is running a tor.exe. that is quite suspicious for us. Okay, and there are a lot of PowerShell running. So PowerShell running on a host machine could be fine, could be malicious also, right? So let's do one thing. Let's see how many PowerShell is we are having. Okay, so we can write something like PowerShell. So just to grep, like just to see what are the PowerShell processes and how many of them are running now. Okay, so you see there are a lot of PowerShell.exe running which doesn't have any of the dots abbreviation. So that means those are not the child process. Those has been initiated as like, the back end of it. Okay, so that's the first trigger. Might be the system is doing something with the PowerShell. Okay, but we really didn't know that what are the other factorial part of it and what could be else. Okay, so one thing we can also check, we can check PSX view. Okay, so basically what is PSX view? So PSX view is give you the tree kind of structure, and it can give you the all comparison thing. If you notice here, there are a lot of things happening like PS list, PS scan, thread proc, PS CID. Each and everything has been given with a boolean value like true or false. Okay, so what it's basically gives, like if a particular process is like trying to hide itself or something, like a similar activity it is trying to do, so you will see that you cannot see it in PS list, you cannot see is in PS scan, but sometimes it can give you in PS CID or something like that. Okay, so now if you see a process which has a false value in PS list and PS scan, but they are true in session and the other stuff, so that's suspicious. Okay, but now if you see, there are exit time also given here. Now if we scroll down a little bit, so you see PowerShell. Okay, so our another trigger. Okay, so what we have seen in the previous command, so PowerShell is true here and that is false here. So that means the thread, there is no associated thread in the memory which is running with the PowerShell, and you see this has been exited from the memory, which is another thing, because then why the process is already also running as like in the process tree, because it is not having a particular memory address that is being allocated to us, right? So that's give you a hint that that process could be doing something malicious. Okay, so now, but still we don't know if anything has wrong, or we have a direct hit, or we have identified something super malicious. Okay, so what we can do now, we can see the the live connections that is being done by the machine, but I am also interested to see the command line that has been executed on the machine. Okay, so now if you want to see the anything else about the command line, what is basically it does. Okay, so command line is a tool, or it can give you that kind of visibility when there is something or someone is running something on that particular machine which is like bypassing or trying to do something, or if someone is trying to write a like a shell, trying to open a shell, anything like that. Okay, so now if you come here, so if you see, there are something which is already catching my eyes. Now you see there is a process ID which is 2572, which has a process like notepad.exe which is calling a file inside downloads named docker.ps. Okay, now we don't know which is the docker.ps file, because we already know that there is no valid use case of that particular machine, but like being served as a Docker file, right? Because we know already, right? Now that has been given by us. Okay, now if the machine is being served as a like a Docker host, Docker daemon, something like that, I can understand, but I don't have any use case for it. So that is catching my eyes. Next thing is that when I see there is something like, tools inside, there is a tor file that is getting run, which is another suspicious thing for me. And another thing, you see there is someone is trying to bypass the execution policy of a PowerShell. That is highly suspicious. And you see there is a bizarre looking file name, and I didn't even know what this file is all about. So what is basically execution policy bypass? So while we create some execution policy or PowerShell, we basically stop someone to run some malicious code or to basically run any script on the machine remotely. Okay, so or by any means. Now if you see some file is trying to bypass that policy, that is obviously suspicious for us, and we should actually check on that file and hit that particular sucker. Okay, now you see there is another execution policy. So you see there are a lot of execution bypass policies happening, and all this, like this is a bizarre looking file, srv something host.ps, there is another ps. So there are a lot of PowerShell. So that is the exact reason we have seen show like so many PowerShell was run. Okay, so let me show you another time. If I can show you, PS list, then I want to simply grep like PowerShell. Okay, so that gonna give me a lot of PowerShell, and I have already shown you that some PowerShell files were there, which is basically trying to do some magic, and they are the parent process, they are not the child process, right? So it's time now to go back to our host and to grab that particular file and to identify and see what is inside that particular file. Okay, so now what we gonna do, we are already logged into the particular machine. Now we can simply go inside like downloads and check, but I know there is no file as called like PowerShell.exe, but I don't want to go and look into that but other files, because that gonna do something on the machine and that can run something. Okay, but what we can do, we have a tool called agent ransack that can give us full information where this docker.ps is sitting on that particular machine. Okay, so what we can do, we can simply run that particular search, and you see docker.ps is giving. Now you see this file is telling, so let me stop this particular sucker because I already have identified something. So it is telling you that the file is located on C:user administrator db data ps code inside that. Okay, now you see if you go to the hits, that is obviously that, and if you see what is inside that file, now you see that's looking a bizarre kind of thing, because I have never seen what is this thing. This looks like someone has obfuscated something or done something else also. Now if you go to the preview, obviously it looks like a ps file, but we don't know. Okay, now what we can do, we can go inside that particular location and like we can try to identify what is inside that particular file. Okay, so let's do that now. So if I copy that particular file, and what I can do, I can simply go here, and what I can simply paste it over here, and I want to open that particular docker file as like anything like code notepad or something. Now you see there is two files. Okay, one is docker file and one is cleanup file. Now we don't know what is the cleanup file, but let's do one thing. Let's open the file, but I don't want to run the file because I don't know what this file gonna do. Yes, it looks like something harmful on that particular file, and oh my god. So you see this is the code that is being run on the machine, which is being called by notepad, and this file was calling itself as a parent process, and this file looks like it is trying to execute the bypass policy. It is trying to do all those stops. Now our intention is that why this file and what is the relation of this particular file with like high CPU usage and all those stuffs. Okay, because we have already identified something, but we don't know what is inside that file. This file looks already bizarre to us because there are a hell lot of data. There are, like all gibberish kind of thing is it's breaking my head, but that's life of our incident responder, right? So we have to break through that code and we need to do some magic to identify what is wrong with that file. Okay, so let's do that now. Okay, so the first thing is that we need to break through that particular file. Okay, so what I'm gonna do, let's create a file, let's say something like stage 1 something, maybe stage 1 anything. Okay, now what I am gonna do, I have just copied that whole gibberish thing into that file, and what I am gonna do, I am simply gonna save it as like that. Okay, so if I do a ls minus or ls simple, so I see the stage 1 file and winpmm is already there. Okay, so let me clear up my screen and let me do a simple cat stage 1. Okay, now the interesting stuff. So you see this file looks like base64 encoding. Okay, now how actually I know this is base64? Now all this thing comes into play when you keep on doing multiple stuffs like that, and it's called like experience. Okay, so you can do that also, but by looking at it you can already identify this is something like related to base64. Okay, so what I'm gonna do, there is a tool which I use very much, which is I call as hurl. You can call as like HURL or something like that. So I'll leave the download link in the description box. You can watch that and you can download that particular thing. It's a free tool. Okay, so now you see if I just type it as hurl, so it can give me all the usage. Okay, so now what I need, so this is like base64, so minus b, and I want to decode that particular file as what's inside. Okay, so let's do that now. So let me clear up my screen and let's do the same thing, hurl then minus b, that's for base64, and there is a file called stage 1. Okay, so let's hit enter. Oops, there is something wrong because I keep on writing wrong thing. Okay, so let's see what is the syntax it is telling us. Okay, base64, then I guess we need to do something flag, then file, and then string. Okay, so let's do that now. So it will be the same thing, and but remember, so we just need to give it as minus b that we have seen for like base64 decode, and minus f, tag f basically for the file. Okay, and hit enter. Now you see this is something like making some kind of sense that this file looks like to be a PowerShell code, and and if you consider it, like there are other stuffs as well, okay, also happening. So you see there are a lot of other strings also. So we have identified something, but there are a lot of stuffs that still need to be done. Okay, so let us do one thing. Let us put it another file called, let's say, like stage 2 maybe, because that's the way we can do it properly. Okay, we can identify it and we can do something like that. Okay, so now if I do a simple cat on stage 2, you see this is the whole thing. Okay, so let's start one by one. So you see this particular thing again looks like to be a base64 decode string. Okay, so let's do one thing, let's copy that particular sucker, and this time what we are gonna do, we are gonna simply learn hurl and minus b, and this time we don't need to give or specify any file name because we just want to convert a particular string. Okay, so I am gonna do that, and now you see this thing is been written as environment then something. Yeah, awesome. So you see this is a minor code, guys. So and we don't know, right, what are the other stuff this particular code is basically doing. So what we can do, we can go to the files, and you see there is a stage 2 file. Okay, so okay, this file is unknown. Okay, I don't care, but okay, so what we can do, open with another application. Oops, I cannot do that. What the hell? Okay, I can open it, right, with any of like fonts or something. Open it, let's see. Oops, okay, that's a problem. Okay, let's do one thing. I can open this particular file, right? Yes, I can open this particular file. Okay, so let's do one thing. Let's create another file probably here, and let's dump everything whatever inside that. Probably I could have write at stage2.txt or something. That's my mistake. Okay, right? Okay, so I don't need this one. Where I was not this one. Okay, so this was our terminal, right? Okay, so let's do one thing. Cat stage 2, right? Let's what I can do, I can write cat stage 2. Yes, I can do that. So let's do one thing. Let's do as cat stage 2. Now let's copy this whole file and put it inside a text file. Okay, so what I'm gonna do, because that's needed, okay, because vi stage 3, obviously I need that because I need to be open at some editable format or something. Yeah, now it looks cool. So what I can do, I can open this as a text editor, and I can keep working on the stage 2 because both files are same, but I am gonna keep on editing this particular sucker. Okay, so now let us go back to our terminal, and okay, so what we did that time, we have identified something. Yeah, this particular thing, right? So let's do one thing. Okay, so let's run hurl again, and yeah, this is the file, correct, right? So what we are gonna do, we are gonna simply keep on copying this particular code, and we are gonna paste it over there. Okay, so our file was there, and you see it was calling it over here. Okay, so now let's what, till here or what? Okay, oh my god, it's it's a long thing, right? So what I can do, I can simply drop it over here, and I'm gonna paste it over here. Looks cool. Yeah, that looks obviously cool. Okay, so now again, let me zoom it a little bit. I don't know if I can zoom it or not, but I hope it solves the purpose. Okay, so I'm gonna save it, and now again I'm gonna go back to the file, and so this is again looks like another base64, isn't it? Something like that, TCP. Then this looks to be a something like a wallet address or something, but I'm gonna open this particular thing up, and I'm gonna do the same with this as well. Okay, so now this might be like a boring stuff, but yeah, that's how we have to do it. Okay, I'll remove this particular thing. Okay, cool. Awesome. Oh my god, so you see this particular thing is giving me another piece of shit. Okay, so it's looked like that they have done something very very specifically, and this file is like something like coded string, inside there another coded string. Okay, and now you see this is not a base64. Okay, so this looks to be a hex encoding. Okay, now what we can do, we can simply do a h same thing, and we can simply -x, because that's the abbreviation of decoding the hex string. And like the way we have done it for base64, this needs to be done for hex, right? So now you see the magic here. So this is finally revealing itself what is inside that file, right? Isn't it very interesting? So what we can do, we can simply go back to that particular file, and we can, in the place of this particular sucker, we can replace that particular damn thing. Okay, so this environment variable, I know buddy what you are done, so paste it over here, right? Awesome, paste it. Okay, so again this thing looks to be another one. Okay, so I'll simply go copy it, and let me clear up my screen, and this looks to be another base 64. So you keep on doing like that. Okay, so I don't want to, like skip the code or something like that, but yeah, I have to do it. Okay, oh my god, keeps on typing wrong. It is called HURL, not UH, something like that. Awesome, right? So another string inside another string. Awesome. So like that way you have to keep on doing stuff like that. Okay, so again URL minus B. I am doing the right stuff. Yes, I am doing the right stuff, Okay, awesome. This looks to be another hex code, right? So what is the code basically done? First, it has, like they have done a full coding. They have decoded it, or like encrypted with a base 64. On top of that, they have done a hex coding, and they have done another base 64 coding, so that our life can be hell. Okay, but I don't care who are you or who have prepared this code, but I'm gonna break through it. Okay, so what X, then this one. Awesome. So I have found another thing. Okay, so what I'm gonna do, I'm simply gonna copy that particular thing, and I know what this particular thing is doing. Okay, so I'll paste it, I'll leave it like that, and I'll paste it over here. Okay, so something is getting, populated, and we know that we are on the right track, right? Okay, so now what next? So you see there is another thing is that also inside that. So service task, and okay, so let's start from here. Okay, now this time we are going to move it from like top to bottom. Okay, so because if that makes much sense. Okay, so we will go back to here, and what we are gonna do, HURL minus B, and then we need to paste it over here, and boom. Okay, as you see, so every damn thing has been coded multiple times. Okay, so I know, like it's a real, like like kind of evil mind of stuff kind of thing. Okay, but yeah, you got the point, right? How actually you things are doing. Okay, now you see we have got another thing which is basically downloading something from a miner of on a GitHub repository, right? So that's pretty much interesting, right? Because we have got another IOC. Okay, so like that way we keep on doing all those stuffs, and we will be able to identify that who has done what. Okay, so now what we can do here, we can simply come here and we can simply erase that particular thing, and we can drop the actual shell bomb there. Okay, oops, yeah, after that I am gonna delete it, paste it, bam, save it. Almost done. So now the next thing is that this looks like to be another one. Okay, so I'll gonna take a quick coffee break, because work is real pain, guys. So, and doing this some kind of like live task is another stuff. What like I can do mistake, but if I do a simple mistake, the code not gonna run, and we are not gonna end up getting the right result. Okay, because there are a lot of stuff that still need to be uncovered. Okay, let's clear up the damn thing. HURL minus something like what else, B. Okay, paste it, done. Yes. So by the way, you can do something like that. You can on the top of it, like we are doing it same thing like multiple times, right? But you can write a simple script which can do this for you recursively, right? So you can do that as well. That's a, like a damn good idea. Why not? If you are a coder, and if you can do that also, like, okay, you see there is another file. So we can simply do that, and you can, you can come here and you can paste it over here. So at this point of time, we have grabbed, some files which looks to be, like malicious, and we are left with only some portions. Okay, so I'm gonna explore them as well, and it looks to be the same one, but let's do another thing. Okay, so why take a chance? So we are gonna do it as HURL, then -b, and then let's paste this particular sucker. Okay, yes, it looks to be the same thing one. Okay, but yeah, so we can do simple copy paste and we can get it away with it. Okay, -x, then okay, tmp yum.exe, right? So we are getting there, guys. So you see this particular thing should store something inside the temp location. Okay, now we are getting there. Okay, so it is storing an environment variable inside that, and it is trying to store it inside the temp location. Now you see there are a lot of things already happening to that particular, coding, because we are getting almost there, right? So you have to keep pace with me, because and bear my lectures, because that's important, right? You can get there with the help of a mad guy. I don't know what even I am talking about. Okay, so keep on doing that. You will get there. Okay, so yeah, another thing. So temp dot something, and yeah, so that's probably the last thing that we are gonna do this encoding. Okay, awesome. And the last string is that it's almost done, and this is the thing. Okay, so we have done this thing. Okay, so what we can do is, this is the same thing, right? So yum, we can copy it from here, because we know we have just encoded that particular sucker. And what we can do, we can simply copy this particular thing, because we know that is OneDrive, and we can paste it over here, because we know that's the same thing, right? So that doesn't make any sense to keep on doing something like that. Okay, so the last pain point is to, like uncover this particular sucker, because we don't know what is inside that. Okay, so let's do one thing. Let's do this, and we will see that what is basically inside that particular damn thing. Okay, okay, so I'm gonna copy that particular thing, and this like a same. Okay, it's again a base64 url minus base64, then we will do a paste it over here. Oops, okay, so I have done something wrong maybe. Okay, so let's do one thing. Let's call it up, Control D. Yeah, okay, so let's do one thing. Let's open that particular file. Okay, so cat stage 3, right? Yes, and this should be easier to copy, isn't it? So what we can do, we can simply run curl again, and we can paste it over here. So again, this is another, hex value, right? So x, and then paste it over here. Okay, awesome. So you see we have got every damn thing what is inside. Now you see we have finally got, guys, which was given in our memory forensics as well, right? If you remember, this particular ps file was having, you know, it was trying to, you remember what it was trying to do? It was trying to bypass the execution policy, isn't it? So this thing is very much important that you need to keep a pace apart with it. And we have finally, you know, done all those steps, and we have the in the final state of it. So what I can do, I can simply copy this particular file, and for the last time I'm gonna paste it over there, okay, because that's the important thing. So I'm gonna remove that schedule task.exe. Yes, because this file is trying to schedule something on back of our head, right? Because that's very much important. And now at this point of time we are almost done with the file. Let me clear up my screen and let me do cat stage 3. Now we have our full code. Isn't it very interesting that from like starting from the beginning, whatever we are doing so far, we have finally, guys, explored what is the gibberish code inside that, and we have explored everything. I could have shown you the file like hey, just one step, then I have showed you that I have done it for you guys, but I wanted to make sure that this episode is a full depth. So I have shown you each and every step of decoding the file and how I have decoded the file. Okay, so now the code has been uncovered. And now what is, guys, so now the interesting stuff is that first thing, you need another cup of coffee. That is very much important because we are like only the halfway done for this particular episode, and there are a lot of things we are yet to cover. So the next thing is that now we don't know where exactly. So the docker.ps looks to be a file which is given by the malware and which is injected by the malware in that particular server. Okay, now we don't know that the file could be renamed something like, and it could be moved to some other location on this particular server. We never know about that, right? Now we could have used our the tool that we have used just now, to identify this gibberish code, but we cannot use that tool another time, because the file could have been renamed, right? So there could be something like we have to run a Yara Scan, and we can create a Yara Scan on base of this full code, right? And you can do that. It's a very simple step, and we are not gonna do it manually. We are gonna run a particular tool that tool is named as like Yargen, that is created by Florian Ruth. So if you want to learn Yara step by step, I have another episode. Follow the link in the description coming up somewhere here as well. But let's create the Yara file right now for this decoded full blown up PowerShell code, and let's run that particular Yara scan on all of our the machines that we have on our network to identify if we have something like some other machine is infected or not, or what this machine is actually, this code is actually up to, and where this code has spawned this child and other stuffs. Okay, so let's do that now. Okay, so we will quickly come out of our evidence folder, and what I'm gonna do, let me do one thing. Let me because this is the stage 3 file, ultimate file, right? So I don't need the stage 1 and stage 2 files, and I'm gonna remove this memory.raw file as well because I don't need that either. Okay, so now if I go back and you see there is a folder called Yargen, and we need to go inside that. Okay, let's do one thing. Let me the evidence folder, right? So that's in our desktop. So for the easy of the process, so what we can do, we can copy or simply cut this particular file inside the urgent file, because that might be easy, because I do not have my the path set properly to use that particular file. So what now, so what we can do basically, if we do a quick ls, so our evidence file is also here. So now in this particular file, so what we can write here simply as like yargen, then okay, so let's call it as simple as like python 3, because that's a dependency. Okay, python 3, then yargen, then another file yargen.python, then -m for the path, and the path should be this one, and then evidences. Okay, because our file is inside that like evidence directory, right? So we can take that as well. Okay, so write as evidences, right? Cool. Let's hit enter, and as you see, our yargen has started. And what this particular file will do, it will create our Yara file, which we need to scan through all of our network devices and all of the files that we might be looking for into our devices to see and identify what is the blast radius. Okay, so let's wait for some time and we'll come back when the yargen has finished its process. Okay, so as you see, the yargen has been finished, and now if we go back to our location and you see our Yara file has been created successfully. Okay, so now here is the deal. So what we basically need to see, if you come here and if you see the condition here, so it is giving you the condition where it is unit. So it is starting as the file information as text, and file size might be less than 2 KB, and any of this is matching, but the file is basically a PowerShell file, right? So what we can do, we can simply remove this particular condition and point the yargen, like point Yara to say that if any of the conditions that is matching from X, or any 4 of them that is matching. Okay, so let's save that particular Yara file. Now what we can do, we can simply come here and in this dashboard area, and we can run our Yara rule to grab what is our blast radius. Okay, so let's do that right now. If we come here to the task section, you will see that there are a lot of things have been done, and triad section. Okay, so here basically you can like create your Yara rules. Okay, right? So what I have done, I have created a Yara rule for like just now, and if you see here, it's the same Yara rule that we have just created. Okay, it's the same damn thing. Okay, so from the yargen and everything, I haven't done anything else. Okay, so what we can do, so the step is pretty simple. You create a new rule and you are done. Okay, so that's awesome. So what next, what we can do now, we can simply come to this task section or like endpoint section, and this is the both of our machines, right, which is our whatever we have inside the network. Okay, and we can write some action, and we want to triage these files. Okay, so what we can do, we can write is as a test rule. That was our Yara, we know that, right? So we can something like malicious file. Okay, because we want to hit that malicious file and we want to know what all those file is hitting. Okay, so we will hit the start button, and you see, if you come to the dashboard and if you see that malicious file processing is started, and if we come here to check those files, so we will see that the processing has been started. And if we see the match, that means if Yara is matching properly with our any of the host, so this process is basically done to identify if there are something which is hidden and we don't know about it, right? So far what we have done the memory forensics. We have identified a particular docker.ps file that was sitting on the machine, and we have decoded that particular sucker, and we have grabbed all of the IOCs, right, from that particular malicious code, or whatever maybe you can call it, From there we have created a Yara's file using Yargen, and using Yargen, now we have done all this stuff and we have created a task on our binarized air console. We are now trying to identify where are our blast radius. Okay, so now I am assuming that this wind particular machine is only infected because that's where the flame started and every smoke started and the CPU usage went high. Now we know by this point of time, right, why the CPU usage went high, because the code was a minor code, right? We have decoded that code, right? Now I am assuming that this particular device shouldn't be infected, but we never know. So we will know that when the full Yara scan has been done. So let's wait and let's have another cup of coffee. We need a lot of coffee, guys, because this is kind of a bootcamp kind of session, but I know and I hope that you are learning something, right? So you can try of your own, like do all those steps and do all those check out my previous episode and there will be detailed breakdown information from each and every step. Okay, so we'll come back when the Yara scan has been done. Okay, now our Yara scan has been done. Now this is quite surprising. We already knew that this machine is infected, but we see this machine is also having 2 matches. So that means attacker has spawned up this machine as well, and this machine is also infected, right? So this machine is the updated version one. So if we go here, so you will see that this machine is the EC2 something AMZ. So I believe this is the same. Yes, so this is the same and we have 2 hits. Okay, so let's open the particular report and okay, file IOCs, and if you see rule name, okay, oh my god. So you see Windows like system32, there is a file. So this file name we have observed in our the memory forensics of the first host, isn't it? And another one is that again another file inside system32, which is Windows PowerShell module defender and defender.psd1, right? So another suspicious thing. Okay, so let's do one thing. Let's grab this particular file. Okay, so what we can do, we can probably copy this particular path, or okay, so let's do one thing. Let's go back to this particular machine and let's see if we can actually see those thing or not. Okay, so recent files. Okay, I'll go inside directory, then I will go inside Windows and obviously system32, right? And what was the file name? I don't remember. So let's open that. So something like SFA FDH, right? So let's hit that SFA, something like that. SFA. Awesome. So you see this particular file is already there. So let's open this particular file and let's see what is inside. Okay, so you see this particular file is the unencrypted format of the actual file, which is the docker.exe. So this file is really doing something bad, right? So now we can surely tell that this particular another machine is also infected. Okay, so let's see that another file, Windows PowerShell and module. Okay, so let's see this file as well, so whether we can identify this or not. Okay, so I'll close this off, and it was also Windows system32, right? So it was inside PowerShell, isn't it? So Windows Defender, I guess. What was the location? Oh, not Windows PowerShell. I cannot copy this. This looks odd. Save as. Okay, let's generate a PDF report. Okay, it's generated now. I believe I can copy the file now. System32, and this here, this is the particular location, right? So let's copy this sucker, and what we can do, we can come here and we can paste it over here. Oops, I haven't copied the full path. That's interesting. It only copied up to this location. Okay, so I don't know. System, obviously it's without system, and inside Windows PowerShell. Okay, so there should be a folder. Okay, never mind. So there should be a folder called Windows PowerShell. Yes, we have got inside the folder and v1. Okay, and what was the file name? The file name was module, then defender.psd. So there should be modules, then there should be a file called defender, I guess. Defender, let's search it. Okay, you see defender is already came up, so let's open this particular. Oh my god, so you see this is the same file, right? This thing we have just decrypted, right? This was the encoded string, isn't it? But this file looks to be a legitimate one, isn't it? So this looks to be a legitimate file which has been spawned by this infected file. So the attacker has tried every sense to hide their this is called as like persistence mechanism. Okay, so this is really suspicious. So at this point of time, we know this particular machine is infected. So what we can do, yes, I can close the session, and what I can do, I can simply contain this particular machine as well. Okay, so I can probably okay, so let's go to the endpoint section, and yeah, so this was the endpoint that we have found, and let's isolate that. Okay, yes, so I don't care, so let's isolate that. Okay, so let's it will be isolated and the machine will not be available in the network. Okay, so its isolation is done now. Now what is interesting part is that, so what are the other stuffs, right? So because we need to identify those as well, right? Okay, so this was yes, I know that. So let's open this particular thing and let's open that report instead, right? Because we know only one location where that particular file was located, but we do not know about the other location. Okay, so now you see this is okay. Okay, so you see all these files, what we have also identified from memory forensics was inside DB data that we have already identified, right? So inside DB data, inside administrator, and inside temp location also there was a file. Okay, so that particular thing, which is obvious, right? Because the file was writing something inside temp location. Okay, so let me open up my forensic workstation once again, and if you okay, so let me open this particular sucker, and I will close this one up and clear up my screen. Ls will go inside quickly, cd evidences, ls, and cat stage 3. Now if you see that this was our so let's do one thing. Let's copy this particular thing and let's see if we can identify something in virus total, right? Because that's totally makes sense why this file is not being identified by any of the AV vendor, because that could have been possibility that the file is basically encrypted. That's why it bypassed the EDR mechanism, right? So this is suspicious. Obviously this is suspicious. So another thing, obviously this could be also suspicious. Okay, so I am not trying to open this up because I don't know what will be inside, but yeah, so if you definitely I can open it. I have a VM, I can open it. Oops, I think I have hit a wrong directory. Yes, so you see this is also a malicious one, right? So now only reason is that when your EDR can be bypassed, because that's an encrypted string, and the EDR could be fooled easily, isn't it? So we have the full EDR capability running on the both of the machines, but still those got infected. Okay, so now what we can do, we can I can close this off because I need to go to the temp location of the file. Okay, so I'll go inside the temp location. Okay, so temp1 file zip, what is inside that? Okay, so you see OneDrive file. As we have seen in the code, the file is actually making a copy of itself. If we come here and if we see that, it should have a copy of yum.exe and OneDrive.exe as well, and it is making the copy of it to the temporary location of the files, right? So that's interesting. Now we should actually see these files also inside our temp location, but we are not seeing this. That is, that could be possibility that since the user has logged out from the machine, the temp location has been gone. Okay, so let's go back to the temp directory. Okay, now you see there is a file called Oracle. So this was also identified in the Yara Scan, right? So if we go back to the Yara Scan report, you will see that, right? So this was the second one. Yeah, so you see this was a oracle.ps one, right? So that was also identified in our Yara Scan. So let this open. Okay, so you see the file name is only different, right? But the file context is totally same. So the file has copied itself to the temp location just to maintain the persistence, just to hide itself from the identification. If you are doing something on the front end, it can keep open a backdoor, right? So that's a possibility. Now you see there is a file called yum, and we don't know what is this file all about. So what we can do, probably let's do one thing. Let's run a quick dynamic analysis on that particular thing. That should help us actually to transfer the thing and to identify what is being wrong. So for doing the dynamic analysis, I bet that you guys can have your own dynamic analysis section also running. I have another video where I have explained in full detail how you can create up your own malware analysis lab and create something like not a very depth level, but how you can cover all those, the beginning stuff of your malware forensics, right? So you can do that. So what I want to do, I want to create a new task, and any.run is an awesome platform which gives you to run anything on it's a kind of sandbox, right? So what we can do, okay, so let me zip that particular file because I cannot actually open that file from here. Okay, and now or let's do one thing. Let's open any.run in the virtual machine itself, so that will be a easier process. .com. I don't know if that is correct. Yeah, that is correct. And I will create a new task, and yeah, I'll upload a particular file over here. Okay, so where is that file? Inside yargen, inside evidence, inside store. Okay, so that's awesome. Run a public task. Yes, I agree. So so what this particular thing will do, this particular thing will basically go ahead and spin up your own Windows 7 machine and try to run that particular file on the machine and try to see what is going wrong on that particular machine. Okay, so we will so now it is loading, and as you see, okay, so open with, you see the process, it's the live process, guys. So it is very much interesting. Okay, so let me zoom in a little bit if that makes much sense. Now you see run 32 DLL is getting loaded, and you see so once this process has been done, you will see that every damn thing which is there in the connection, in the DNS request, everything will be popping up over here. Okay, so that's very interesting stuff, and I will just go back and I will just complete my other task because I need to quarantine that particular machine as well, right? Because there are also some other stuffs. And now one thing also you can do, there are two files, right? So that has been identified, right? So one is yum file. So what we can do, we can make a zip of this particular file. Let's do one thing, let's send to a quick zip. Okay, and let me take this file to my own machine. Okay, so that I can run a quick static analysis of the file, just to identify what are the challenges and what are the main the abbreviation of the file, so that I can, if there is any other left of IOCs that can be present. Okay, so if we come here and if you see, there are like no DNS request has been sent or no connection data, because the domain might not be live, so we can also identify from using that. Now if you see here, there are like some hashes that we have, I believe we have already identified. So there are nothing much. Attack matrices also we can see, which is very interesting. Now you see discovery, query register, and system information discovery. So now you see this particular file is basically using run32 DLL, right? So that could be a possibility that it has spawned up with some other instances or something like that, to identify what all the information was present or how our network actually looks like. Okay, so that way it might have identified our environment, and it have spawned to the second host as well. Okay, so I'll close that up. You can run the malware investigation on your own own lab, if you have a lab, right? So you don't need to run, or you don't need to even use any .run, because always I suggest you always you can use your own machine to host up a malware lab, and you can do all those stuffs, right? Okay, now the interesting thing is that we will simply do a simple static analysis on this particular file, just to identify what is the tactics, what are the other features that we can use, or we can if we can identify something else. Okay, oops, so ls, yes, yum.exe. Now I have another tool which is called as kappa. So the tool is basically created by FireEye, and it's a freeware tool. I will leave the link in the description, you can download that. So what this kappa will do, so kappa can give you the exact details of the file, which is like the static kind of analysis. It's kind of, it will give you the PE headers, it will give you the tactics, it will give you the all information, if there is any evidence or something like that. Okay, so it can be done, and it is very much useful, guys. Okay, now you see this is a very important stuff, because this sample appears to be packed. Okay, so this is another example that you cannot identify what is happening inside that. Okay, so now if you want to see the capabilities, you can use something like v or -vv. So let's do one thing, let's do a -v to identify if we can identify something else, or we can use virus total as an evidence collector, and you can give it what is inside that particular file and what is not. Okay, so let kappa analyze the file, and we will come back when the analysis is finished. Okay, so as you see, kappa is still running, and it is like 33%. So what we can do, I have dumped the docker.ps file from the malicious machine, and this time I have just renamed the file as docker.ps, because that was an encrypted file, and it was basically our unencrypted version that we have in stage 3, but I renamed the file as ps1, right? Because last time we did the analysis on like it could be a simple text file, so the file might not have run properly. But let's do one thing, why I thought, why not give it a try, that let's see if this is a particular like a PowerShell script. So let's give it a try to see if we run that PowerShell script, what all happens to the machine, like the way we can actually identify like what are the tactics that has been used by the attackers and whatnot. Okay, so as you see, this like code is getting run on the machine, and you see the PowerShell is getting called and task scheduler is getting called. Okay, so this is a interesting stuff, right? So task scheduler is getting called, so that means it creates a spawn process on the machine which keeps on calling the minor code repeatedly, right? So that's another process of maintaining persistence. Okay, and we have identified the files in OneDrive, and this temp location, this file we haven't identified, but it was there in the code itself, right? So the tasks, so basically what is happening, so once we call it the file, the PowerShell is getting called and task scheduler is getting run, command.exe is getting opened, and it is copying a OneDrive file in the temp directory, and it is calling another file, the task installer in the temp location. Okay, so now so I see this is done now. Okay, so this is done, and you see all this file like OneDrive and all those files, and we are, by the way, we are doing the analysis on the yum. Okay, so you see this is almost done, but we will come back here. Let's first understand what is happening. Okay, so you see there are two connection made. You see this is another IOC. Okay, so domain, GitHub, and this is another IP address. Okay, so this we have identified another IOC. Okay, so this IP address we haven't identified so far. This one we have seen because that was hard coded in the code itself. Okay, so where is the DNS request going on? Okay, so this is the DNS request. So if we see that and there is no threads. Okay, let's go back to the IOC section, and you see these are the all IOCs we known, but this was a new IOCs as the IP address IOC that we have identified just now. Okay, interesting stuff. So you can, by the way, you can do all those things by your own, but this actually gives you a full depth of analysis. Now you see this is the whole thing happening. Okay, so the first, when we kicked off that particular PowerShell code, what it will do, it will kick off a task scheduler that we have told you, right? And inside the task scheduler there is no space. Okay, now if you see here, the there is no specification. Okay, now if you see the command line, okay, so it will, obviously it is giving you the exact command line what is it was doing. Okay, so out of 100 it is matching you 10. Okay, so it is suspicious. Okay, so command line exe, it is creating like a process which is -tn, and it is basically, you know, trying to execute the execution policy which is trying to bypass it on the PowerShell, and it is creating a like code which is ps.1, which we have seen in the first memory forensics, and we have also seen this file in the second machine as well, and we have seen this file in the temp location as well. Okay, so now this is dangerous, and so we have seen how this particular PowerShell is working. Okay, so now let's see what is this CMD is doing. Okay, so CMD is storing a file which is OneDrive.exe inside our temp location. Okay, so we have observed this file as well in our temp location, isn't it? So if we go back to our machine, I will assume that this particular file will have inside the temp location. Let's see. Okay, so might be the OneDrive file has been removed or something, but it should be there actually. Okay, so we know there is another file called OneDrive. Okay, so that was anyway hard coded in the code as well. So what it does, it is, okay, so now what is doing, so once it is moving the file, another file called tinstaller, it is calling basically the -script. Okay, so if you see here, let me scroll up a bit and let me remove my face if that is coming in the way. So if you see here, this particular thing is calling a pool DNS, so that is obviously the minor pool DNS, and this particular thing looks like to the coin miner wallet address. Okay, and it is calling the XMR -string. Okay, so if we go to the more info section, you will see the what exact process that we have seen the PowerShell and by which SID it is running, like what are the other command line and what is every damn thing you will see over here. Okay, so we don't see any registry changes, but it was a straightforward. Okay, so now the last thing is that it was a last command process, and let's see at this as well. So this is also doing the same thing. Okay, so I'll do it as like that. Okay, so more info, if I go to more info, what it is basically doing, this is basically doing the same stuff. Okay, so user is admin. Okay, and basically it is running the PowerShell as an admin user. Okay, so it doesn't have any children, but yeah, it's a simple command and it doesn't have anything else. Okay, it's simply calling the minor domain. Okay, now let's go back to our kappa and let's see what kappa has done. Okay, so now if you see, it couldn't identify any of the anti-anoise packer or something like that because the file is heavily packed. Okay, so what we can do, but we have got the hash values of that particular file, so let's call it as, and let's see, let's open our virus total. Okay, I think virus total opened in my best machine, so I will copy it over here and let's see if virus total can give us some hit. Obviously it is giving us some hit, yum.exe, and it is exactly telling what is this file is all about. Okay, and if you come here and if you see coin miner, okay, bitcoin miner and coin miner, every damn thing, bitcoin miner. So one thing we are now sure that coin miner was installed on our machine, which was spawned by another process, might have been. So we, at this point of time, we really don't know that how the bitcoin miner got infected to that machine, but we have identified whatever happened so far, how the thing has done, whatever we have like the code in infection from the starting itself, we have done every damn thing. Okay, so let me recap the whole thing really a quick bit, so might be that might help you guys to understand what went behind the curtain. Okay, so what actually we did from starting, let's recap. So we had a black box, okay, and we started analyzing the box from memory forensic angle, and we have identified some docker.ps code. Okay, and the code was full obfuscated with a gibberish kind of text or whatever you can call it. Okay, so from there we have decoded the full code in two-step process, and we have identified the stage 3 parameter, which is the actual unobfuscated code, and we have grabbed some of the IOCs from there. Okay, then we have used Yargen to actually write the Yara rule for that particular the PS code, and we have ran that particular code using our binarize air, and we have identified that both of our machine is infected actually by that minor code, and attacker has spawned all of their child processes inside all, like, both of the machines. Okay, so in the real case scenario, if your EDR is not able to handle that properly, and if you have some kind of this kind of feature like binarize air in your arsenal, so it becomes very easy to run all those stuffs. Okay, so that's exactly the thing we have did. Okay, so once we have identified, we have isolated one of the machine, that was the second machine and the updated machine, and then what we did, we have basically went to the other directories of the file, like from the static analysis and the dynamic analysis, we have identified some other files also, right? So like OneDrive, then yum.exe, which was sitting on the temp location and all those stuffs. Okay, so we have tried to grab some of those files, and we have run on our static and dynamic analysis in any run, and using kappa to identify if there is any other IOCs available, and we can block it and we can take action on top of them. Okay, so at this point of time, we already know what is our blast radius, how that incident actually, after the delivery phase, how the incident propagated, what is happening on that particular box, so that the machine was with high CPU usage. Okay, because that was a minor code, guys, that was running on the machine, and that absolutely validates that if your machine is running with 100% CPU usage, that can blown up, and like fire is obvious, right? So that's a highest minimum situation, okay, that can arise, and it's a very critical situation. Okay, so that can arise to any of the SOC, but I wish that shouldn't happen to any of you. Okay, but yeah, I hope you have learned something, and don't forget to participate in the giveaway. So I have already mentioned and mentioning once again, so you have to share this particular post in your LinkedIn profile, tag me and tag BlackPerl, and come back here in the video and comment here that you are participating in the giveaway. Okay, so yeah, all the best to you guys, and I hope you have enjoyed this particular session. If so, please do a thumbs up, because I have like put forward a lot of effort for you guys to make this particular episode, starting from demo environment, spinning up, then talking to people to actually analyze it, then also arranging the giveaway for you guys, right? So I think I deserve one like, right? And if you and your folks want to understand more about DFIR, so do all those YouTube stuffs like share this video, and anyway you are gonna share this particular video to participate in the giveaway, right? And the other stuff is also, don't forget to subscribe, because as long as I can grow, I can give you back also this kind of giveaway coupons and all those stuffs, right? So you help me and I help you to become a successful DFIR and SOC or cybersecurity practitioner, or anything for that matter, right? So yeah, that's all, and stay healthy and stay tuned for the next coming up series. I hope you gonna enjoy them very much, and I will catch you guys next time. Stay healthy.